Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Thank you very much for joining this particular platform that celebrates you, industry professionals all around the world. You are bold, brave, you dare greatly, you innovate, you collaborate, you solve problems, you are making the world a better place. That's why we celebrate you on the #1 industrial-related podcast in the universe. It's all backed up by data. And we are broadcasting from PowerGen here in Dallas, Texas. It is a great event. It is the last day. It is starting to wind down, but still there's a lot of opportunities to be able to sort of kick the tires of all this wonderful innovation that is on the floor. It is, if you want to get into a profession, you need to look into anything dealing with power generation. It is a really fantastic market to get involved in. All right, he's been on the show. It was a number of years ago. He just wandered up to my broadcast booth, Buddy Lee. He is with Mesa Associates, and we're going to be talking about everything. We're going to talk about everything, so let's get cracking. Hi, Buddy.
Good morning.
It's good to see you again.
Yeah, it's good to see you, Scott.
Yeah. It brings back a lot of good memories. I think we were in Florida when we first connected, and that was a great conversation.
Yeah.
All to do around reliability, asset management,
right.
Maintenance, and all of the strategies associated with that.
Sure.
Can't complain. Coffee in hand.
Yes,
all
sir.
good, ready to roll. Early morning.
Yeah.
Who can complain?
Let's open it up for artificial intelligence and asset management.
See?
I mean to tell you, I love these topics.
Yeah, because here's the funny thing. He is the AI subject matter expert, industrial application. It's a mouthful for Mesa Associates, but it's a big title, but he can handle it. So yeah, before we get into that and all of this stuff, because AI is a real, interesting topic.
Absolutely.
Give us a little background on who Buddy is.
Sure. Buddy Lee, I'm hail from Knoxville, Tennessee, in that area. I actually live just outside of Knoxville in a beautiful town called Dandridge, Tennessee right now, second oldest town in Tennessee, and Davy Crockett is from Dandridge. So my aunt actually married into that family. And so I've grown up in East Tennessee my entire life. I've attended the University of Tennessee. I also attended Carson Newman College. Got my first degree in 1982 in church music, and then got a second degree in electrical engineering at the University of Tennessee in 1987, and then did a MBA at the University of Tennessee in 2013, and then got a master's of engineering at the University of Tennessee in reliability engineering across discipline function, and got that in 2021 when I was 61 years of age.
Shut the front door.
Yeah.
And by the way, as you can tell, if you're out on the video, you can tell that he's a big fan of Tennessee, because he's got the colors going and the pin hair and all good.
Rocky Top, baby.
Rocky Top.
Yeah. Best fight song in the USA.
Yes, it is. I'll go with that. I'll support you on that one. So let's talk. You're having a good conference.
Yes, sir.
Have you been to this one before?
I have. It's been a number of years since I've been to it, but it's a huge conference. It's an excellent conference if you want some good technical information, and more or less you want to get in the show, on the show floor particularly, and learn about all the new equipment and technologies that are coming out. This place is huge, and it is a great place to come to if you're in the power industry, which is kind of a staid industry. It's been around for a while, but boy, we're seeing some really nice new things in, small modular reactors coming out. On the nuke side, we're seeing developments happening even, in hydro. My gosh, there's some nice AI stuff happening in hydro these days. And so it's an exciting time to be back in the power industry and coming to this conference. I'm thrilled to be here.
I have to sort of go off on a tangent real quick. Is somebody doing a small modular reactor out here? Have you seen it?
I haven't seen that yet.
No, I have not either, but I know about it. I mean,
We have them in Oak Ridge, just near me,
actually,
and that's a big topic of conversation around
Yes.
the DOE and those areas. And since Mesa, what we do is design electrical things. We are involved in some of those, I think, interconnects and things like that they're doing. But again, that's not my particular area at Mesa, but it's an exciting time with all this new stuff that's happening, and the data centers are driving a lot of that. So AI is actually driving the power demand curve up, and we're seeing some. It's just an exciting time to be back in power.
It is.
Yeah.
It is. So let's talk about AI. We might as well just recognize the elephant in the room right now and talk about it. What's your role with Mesa and being the AI SME?
Yeah. So one of the things I did when I got my Master's of Engineering at UT was I did a thesis on using artificial intelligence models with very limited data sets. And the data set I was using was vibration analysis coming from a data collector. I happened to have access to databases. It was over a 7-year time period where data was taken on a paper machine. And I was trying to compare, would AI model in particular, so I didn't want to use just one, I did use 30 models and compared all of those against what a human analyst would do, because I had this 7-year database of when a human analyst called a bearing bad on 4 different paper rolls in a paper machine in North Louisiana. And so I could compare how well the model performed against a very limited data set. Data was taken once a month, unless it was, going bad, and then they would take it more frequently, of course, and they would take higher resolution. So, he could get a real good idea of when the bearings were actually failing. And so I was interested, would the AI models that are just formed right in MATLAB, if I trained them on the data, would they give me accurate time frames against what a human would call it? Okay, and I found that 5 of those models would give me 95% accuracy in what a human would call for a bad bearing.
But how many models were you using?
30.
30.
Yeah, so I took these time waveforms over a 7-year time period, so you can imagine how much data that is.
It was huge.
You're getting a lot of data.
And it's still sort of funny because that's considered a small language model. It's still compared to the large language models, which is just...
Well, there's a little bit of confusion in terms there. This is a large data set, but not a large language model like you train against ChatGPT. Okay. So those are separate things. Now, we do use a small language model in terms of and what I'm doing right now with Mesa. In terms of this, what we're doing is we're using failure modes and effects analysis, FMEAs they're called. Sometimes you put criticality analysis on the end of that. It's a FMECA. Right. But we use those studies that are done out there, and we say, okay, we got a template, and we kind of know for a particular machine how it's going to fail and what the effect of that is. And so we can take the data from all the various data sources, very disparate data sources, maybe vibration, temperature, pressure, flow, etc. Current draw. We can take all of that and put it into a system and say, okay, have the relationships between all of these sensor values changed? And if so, that's an anomaly. And that will give us earlier detection than waiting for a set point to actually fail from, say, a vibration data point. And so we can look at those anomalies and we can say, okay, now if this is giving me earlier detection, does it fit within my failure modes and effects? And I can actually ask the system questions, and it's a limited large language or a small language model against those FMEA templates with all the data inputs that are coming in, all the data against that. And I can say, okay, predict for me the efficiency of a boiler for the next 3 months. Or I can ask it a question like, what happened when this bearing went out on the thrust bearing? And we found cases where we're seeing anomalies 4 months prior to a set point failing on a vibration system, for example. So we're getting earlier detection, which is a good thing from a even from just a supply chain standpoint, much less labor, that you got to put in the field to fix the problem. Getting that earlier is just a fantastic thing, because I can plan for it better, I can buy it cheaper, I can do a lot of things that I'm not reacting to a problem in real time, which is absolutely the worst thing. We used to call that run to failure maintenance, but that's still done appropriately on some equipment. But, in heavy asset industry like we have in power, we really want to do that in advance. And this anomaly detection from the AI engines that are running and the machine learning, and then just being able to use that like a chat GPT interface to say, okay, predict for me when the next failure is going to happen on my thrust bearing because my oil temperatures are up. Okay, and then it will give us an idea, and we can from that have a human in the loop, so it's a supervised system, but he can say, okay, I look like I have about 3 months of remaining life on this before I have to actually do something that set point's violated. And so that gives me a lot better idea of how to get all my pieces and parts together to get it fixed.
Are you taking these models, and are they, is it in production right now?
Yes.
Okay. And are you seeing accuracy there, like saying 3 months to failure? You see it, it's happening, you have the data. Is it accurate? Is it?
Yes, it's extremely accurate. In fact, we're seeing, if you want to get out of the realm of industry for a second and see where it could conceivably go, look at what Tesla is doing. Tesla is collecting millions of data points from every single car that they have on the road all the time, and they're trying to react to a much bigger model than we're reacting to.
Huge.
It's huge. And what they're doing in real time is driving a car. Okay, so yes, it works. It works well, and it works at lightning speeds that a human can't approach. Okay, what a human can do is be the fail-safe in this if you ever want to put it in production, okay, in an industrial plant. That will be slower for us than driving, okay? Tesla's pushed that boundary. So it'll be slower for us, and frankly, there's a trust problem still. There's still the culture issue with AI. It scares a lot of people. They think Terminator and the old movies and all that. Yeah. We're not talking about that. We're talking about machine learning. We're talking about a subset of the generative AI that everybody knows, chat GPT and the generative AI. We're really talking about a subset of that called machine learning, where we actually use the data that's been generated by the machine, and people out there are collecting all kinds of data. We're getting data out the wazoo, and it's going into a historian mostly never to be heard from again. But what we can do is we can go back into those historical data banks with the AI and use it to train models, and then apply those in real time to what the incoming data is looking like, and we get a much better idea of how to operate our machines. Frankly, most of the problems that are out there, and this is very true in the nuclear industry, most of the problems that happen out there are human caused.
Yeah, I was just going to say, once you open that asset up, then you have the potential of introducing another issue.
I'm really speaking, yes, that's very true. I'm really speaking more about operations, on the operations side. I mean, look at what happened at, what was the one in Ukraine, the nuclear plant, Chernobyl.
Yeah.
Chernobyl was caused by somebody going off the rails and doing tests that they weren't supposed to be doing, and violating their own procedures and their own. I don't know if you ever saw that Chernobyl special on HBO, but basically that was a human-caused event. That whole meltdown was caused by a human. And so Fukushima, that wasn't. That was weather related, right?
That's
can't
tsunami. You can't do anything about that.
Right. You can't. But there's a lot of human operations problems that happen out there in industrial plants, and that's an extreme example, at that plant in Ukraine. But it's a very important lesson to learn, as we are operating these machines. They have a specific sweet spot that they like to, they call it best efficiency point, for example, on a pump, where they like to be operated. And a lot of times they aren't operated near that, and they cavitate, and they cause all kinds of issues, especially as they empty a tank and the suction pressure goes down. They start cavitating, and they start eating up the impeller. And before you know it, you got a pump that's not operating anywhere near its best efficiency point, because it's probably oversized in the first place by the engineers that designed it. So you have some design problems that come in, but mostly it's operational problems that happen out there in industrial machinery. And I'd like to help clean that up, and I think that's what the promise of AI really helps us do. Operators are fantastic people. This is not to denigrate them at all. It's just in the way we operate it on day-to-day and trying to meet goals where we're trying to get product out the door and things like that. These market pressures come into play. My gosh, there's just so many things that can go wrong that AI can help us, be the gutter guards in a bowling alley where it keeps us out of the rails. AI can keep us in the center spot where we hit a few pins.
So here's the question that everybody asks.
Sure.
That sounds great. That's all wonderful. How fast? How fast can I begin to deploy an AI strategy at my facility to be able to manage my assets more effectively?
Yeah.
And for...
Let me tell you, fast enough to make you uncomfortable. Okay?
Oh.
Yeah. I'm talking about we can do a model and deploy it in days. Honestly, if we get the data in. Now, to get the data in might take a week or two. But to start getting some good ideas of how your machines are operating, what those anomalies are that the system can detect is extremely rapid. Some models, and it depends on how complex it is. If you're doing weather patterns, that's a hugely complex model, right? But if you're just talking about a machine and its operation, it's supposed to be at a certain temperature, pressure, flow, certain balance of mass going through a machine. We know where that's supposed to be in most design applications in industrial plants, particularly in power because we're so regulated. So, I really think that these systems can be brought up fast enough to make people uncomfortable, and that's where we get back to the culture question of, oh my gosh, is this thing taking over for me? And frankly, no, it's another tool in your toolbox is all this is. But
what do you get the data? If I'm a new company and you come on in and you just say, all right, let's do it. I see the benefits. I want to be able to deploy this. Where do you get the data that you feel confident with?
Yeah, that can be part of the problem. Okay, now you just said the important word, confidence.
Confidence. I'm telling you. Yeah.
So. We do vet the data considerably and ask questions like, is there too much noise in the data? What's the signal to noise ratio? We ask a lot of questions of the data, and that's probably the first day or two, maybe even longer. Just depends on how big the data set is. People are recording this data, they're sending it to a historian. All we do is pull it out, and then we use a lot of statistical tools to tell us, is this in the right range for what it should be? If it's not, then was an anomaly detected during that time? And so we do historical look backs at the data to see if there are problems already in it. And that sometimes involves us going to the computerized maintenance management system to say, okay, was a work order issued against this, and to say the fan was balanced, and all of a sudden we're back to good things. We don't want to train on a model that's already got bad data in it.
Yeah, because that's always that's it. It's just when somebody says, hey, I want to be able to collect the data, I have data everywhere. And everybody gets down to the point of how much confidence do I have in that data? How do I scrub that data if I want to scrub that data? How far do I go back to scrub that data?
Yeah.
And from what I understand, buddy, we're talking about there's not a need to go way back.
Right.
You can begin starting to unearth.
Look, if you've got 6 months of data, that's good. That's approaching the right number we need. If you've got 2 years, we prefer it. Okay. If you got a couple of years of data, if going back much further than that, you're really into the unknowns. People haven't documented things that well going back much more than 5 years. They have data, but the documentation may not be as good. Some people have data going back to the late 90s, and stuff like that they have in their PI systems, their plant information systems, and other, historians. But, I think if we can get, 12 to 24 months of data, we can do a real fine job in getting a model put together in a very short period of time. Now, is that a deployable model? Maybe, maybe not. We may need to fine-tune that model. It may take some extra time, but is it good for a pilot program to get, a win in quickly for you so that you can expand the program? Yes, we can do that sort of thing all day long, twice on Sunday.
Speaking of pilot, if you look at a particular organization, a business, power generation, whatever you're looking at, do you take a pilot and you just say, hey, what's your one of your most important assets. Let's drive a pilot here.
That's how we do it all the time. Yeah. We actually look at a particular asset. Say it's a hydro turbine.
Yeah.
Well, we might look at the vibration sensors. Maybe they have a Bentley system on it or something like that.
Yeah.
And we'll get some vibration data out of that. We may have an iris system giving us the air gap, reading. We may have oil temperatures. We may have a bunch of different stuff, and we may have to run it through several models to see what the parameters are that we can draw out that give us good insight into the developing problems. If we can get your FMEA, if you've got one, now we can develop one too, okay? But if we can get that, if you've got it already, and we can get a couple years of data, then the deployments go extremely rapidly. And I think it could be very useful for people. And of course, you always train, then retrain, then retrain, then retrain. You're always updating your
because
model.
you're always getting more data, more information.
Sure.
And I would imagine here's a GE motor down here in Dallas versus a GE motor, the same GE motor, but it's up in Maine.
Yeah.
And you're just able to really continue to sort of hone and bring that data together
now
to be able to do it.
Yeah, and you're absolutely correct. Now you're into seasonality on your data, and there's, down here on the Gulf Coast, you're going to suffer a lot more corrosion than you are up in, Maine. And so this is where your SMEs come in. Your subject matter experts that are in the plant have to know what the predominant failure mechanisms are and what they've done for their FMEAs and such. And if they've got that data, then we can do a real effective job of giving them another tool in their tool belt that helps them understand what's going on inside the machine in their region. And I think that's really important to do that, because you don't want to train a model in Maine for something you're going to run in Houston.
No, you don't.
It doesn't make any sense. Yeah.
But that information is all feeds into that model,
right?
That gives you just a greater insights into how to manage that asset.
Right. So we're seeing the OT guys, the operations technology guys, and the IT guys. They're basically instrumenting plants across. Now, there's still a lot of work to do in instrumentation of putting the sensors out there and that sort of thing. And that brings up the whole concept of digitalization. Yeah. Seeing a ton of work going on in that in the steel plants that are out there, not related to power, what we're doing here, but I'm seeing a ton of work there. I really want to, if I can in any way, influence the folks in power to copy the model that the steel industry is doing in terms of getting their equipment instrumented. We're seeing some of that in some of the hydro plants out in the Northwest. They're doing a lot of instrumentation right now, spending a fair amount of money on that, and they're going to be getting much more data in than they've ever got before. So this is getting bigger. Now, the IT guys and the OT guys have a little bit different perspectives on what to do with that data, but they still have to get the same data kind of in. And the idea here is that they will have security concerns, particularly in the power generation industry. They don't want somebody shutting down a turbine, external bad actor, right? Yeah. So there's a lot of that going on, and you will probably have this particular industry looking at doing everything on premise as far as their data. So that means we're going to push the computing. Yeah, we're going to push the computing down to the edge of the machine. And then we're going to get the parameters out that give us the story, and we're going to pop that up and populate it into a dashboard somewhere on some operator's desk, and that's all going to be internal to the specific, say it's TVA, Tennessee Valley Authority or somebody like that, or Duke. You're going to have all of that stay within their air-gapped systems that don't go out to the internet and don't do anything, which makes a lot of sense from a security point of view. Yeah. So all of the AI vendors, including us, are aware of the issues that are happening there, and so the IT guys are influencing the OT guys, and they're putting their SCADA systems out there, their DCS systems, individual sensors, running all that data in and into their internal historians, and all that's going to stay on-prem. And so a good AI vendor was going to understand all that and help you keep it on-prem. There's very few that I think will actually stick it in the cloud, because
no way.
Yeah.
That's a whole other conversation.
That's a whole other conversation. Yeah. Not one I really I can get into it today if you want to, but it's kind of external to this particular conference.
Well, we got to wrap it up just because you've just been chirping really well. I mean, this has been a real interesting conversation. How do people get a hold of you? They want to know more about this whole AI stuff.
Well, they can get a hold of me several different ways. I am an adjunct professor at the University of Tennessee, and so they can get a hold of me through my Tennessee email. They can get a hold of me through my work email, llee@mesainc.com. They can call me on the phone, 865-388-3802, and of course on LinkedIn. If you just look up LinkedIn Buddy Lee, I'll come right up, and so I'm happy to converse. I've got about 5,000, I think, followers on LinkedIn. Happy to converse with you there.
Front door. Yeah. That's always the easiest way.
Yeah,
because it's easy for me to just put a link on my website.
Yeah.
Which brings me to the point. Thank you very much, buddy, for popping in. It was great to see you again, man.
Great to see you, Scott.
Excellent. All right. We're going to have all the contact information for Buddy out on Industrial Talk, so fear not. Reach out to him. AI is happening whether you like it or not. Figure out how you can leverage this tool to help you manage your assets more effectively. It's there. It's happening. But you need a Sherpa like Buddy to help you along with that journey. So connect with him out on LinkedIn. All right, we're broadcasting from PowerGen. Dallas, Texas is the location. And again, you get incredible professionals like Buddy. If you didn't attend it this time around, make it a point to attend it and get into the power industry. It is a fabulous industry. All right, we're going to wrap it up on the other side. Stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Two letters, A and I. It is going to impact you in some way, shape, or form. You can't be afraid. That's Buddy Lee. You need individuals like Buddy Lee to help you along with that journey. Yeah, it's here to stay, whether you like it or not. You can have positions like, I really just want to have that human component, whatever. But if you're in the world of trying to collect data, analyze that data, refine that data, gain insights into that data, that's a whole AI value proposition. That is a must. So learn it, figure it out, get your team on it, talk to us. We'll help you along too as well. And speaking of which, Industrial Talk is here for you. You need to amplify that message. You need to market more. You need to create that attention that is necessary for you to succeed. Go out to Industrial Talk, connect with our team, and you will not be disappointed. Be bold, be brave, dare greatly. Hang out with Buddy. Change the world. We're going to have another great conversation shortly, so stay tuned.